All right, let's look at the remainder of our application problems for Chapter 16. These next few have to do with our formulas from the pH section. So the first question tells us a hydronium concentration and wants to know what the pH is. So here's the pH formula. And we would fill in the pH that we're given in the question in the place of those brackets. And then you're ready to plug that into your calculator, and you want to, in your calculator, either make it look just like that or use that button, that small caps E, which means times 10, and then what you put right after it is the exponent for the 10. And when you put that in your calculator, you should get a pH of 3 for this question. The next question is a little bit of a trick because it tells us a concentration and asks for the pH. It looks very similar to the previous question, but it's not the same because the concentration that it's giving us is the OH rather than the hydronium. So we can't plug it directly into this formula because that formula doesn't have a place for the OH. What you can do is use the pOH formula because that formula looks very similar. It uses the negative log, but you can plug the OH concentration in rather than the H3O concentration. And if you plug that in, it does now look just like the one that we just did, which means that the answer is going to be 3, but that's for the pOH, not the pH. So we have a second step to this problem, which is to find the pH, and we'll use our simplest formula for this chapter, which is the fact that the pH and the pOH always add up to 14. So if I found the pOH, I could just subtract it from 14 and get my pH of 11. Okay. Number 17 is a 3-part question in asking kind of the same thing that some of our review questions asked in a practice last week. So the first one asks for the OH concentration, and you can see for all of these we are starting with the hydronium concentration. So if they ask you for one of the concentrations and they've given you the other one, this is the formula that we're using. You would take 1 times 10 to the negative 14, the ion product constant for water, and divide it by whatever concentration you're given in the question. So plug in the concentration given in the question. And then you're ready to put this in your calculator, and it comes out to, in your calculator, it come out to about 1.136, and then it keeps going, and then at the end it says it's times 10 to the negative 13. And so if you round that just so it has the same number of digits as the number in the question, it would look like this. That's for our OH concentration. Okay, next it asks for pH, and we'll use the same negative logarithm formula that we just used. So again, the H3O concentration is 8.8 times 10 to the negative 2. And you'll put that in your calculator, and for pH and pOH answers, you should not be getting scientific notation. You should get a number that's between 0 and 14, and we do. Our calculator here will give us approximately 1.055, and it keeps going, and you can round that to either 1.1, or if you did 1.06, that would be fine, something like that. I'm going to use 1.1 for now. And that's my pH. The last thing it asks for is the pOH, and the simplest way to find that would be to use the previous answer and plug it into this formula that we just used, the fact that pH, and pOH should add up to 14. So you would take that 1.1 and subtract it from 14, and you get 12.9 for the pOH. All right, let's look at the last few problems. Numbers 18 and 19 asks what salt will be formed in a neutralization reaction between the given acid and base. So as a reminder, the cation is the first ion in the base formula, whatever's in front of the OH, and the anion in the acid formula is whatever is after the H. It's the second part of the acid formula. Cations are first, anions are second. So in number 18, sodium hydroxide is my base. I can tell because it has an OH. And I'm just going to mark that OH out so I can focus in on my cation. Na will be part of my salt formula. Then over on the acid formula, mark out the H when whatever is after it is the anion that you're going to stick with your cation. And that's what our salt is. Sorry, clean that up. The next one adds just a little bit more of a trick, but it's not too bad. It's got phosphoric acid. So on the acid, again, mark out the H. And the trick here is that if there is a subscript for the H or a subscript for the OH, you don't mark out the subscript. That's going to stay as part of our salt formula because that 3 came from the charge of the phosphate, so it needs to stay with any formula that phosphate's a part of. So this is going to be part of my salt formula, the 3 and then the PO4. The other part of the salt formula comes from the cation of the base. So if I mark out the OH, I can focus in on that cation, the K, and that goes in the beginning of the salt formula. All right, numbers 20 and 21, I did not ask correctly because it asks for the neutralization reaction and I didn't actually give you salts, I gave you acids. So we're not going to be able to do 20 and 21. The only type of problem on your test from that section will be worded like 18 and 19. All right, the last type of problem for the chapter was in the titration section. And it uses a fairly simple formula. Quick review of what the parts of the formula are. The M on both sides stands for molarity, or the concentration. The V on both sides stands for volume, and that'll be in milliliters. The K's are the known numbers, so the one substance that you know two numbers for go on this side together, and then the U stands for the unknown. So you're going to be solving for one of those two, either MU or VU. All right, so let's look at our question here. It says in a laboratory titration, we have 18.74 milliliters, so that's a volume, of a solution of hydrochloric acid, was neutralized by 27.8 milliliters, that's another volume, of 0.0750 molarity. So that's a molarity. And since the sodium hydroxide is the substance that I'm given two different numbers for, this is my known substance. So I'm going to keep these two numbers together as my known volume and known molarity and plug them in over here. So my known molarity is the 0.0750. My known volume is 27.08. And then on the other side, I don't know the molarity, that wasn't given to me, and in fact I can see in the rest of the question it is what I'm asked for. The unknown volume, or the volume of the unknown substance, is 18.74. Now I'm ready to solve for the unknown molarity variable by dividing both sides by 18.74, and I'm ready to put this into my calculator. All right, and it came out to 0.1083, and it keeps going after that, but I'm going to be rounding my answer so that it has 3 significant digits. Just looking back at what I was given in the question, my volume numbers have 4 digits, but this molarity number just has those 3 significant digits. So I'm going to put my answer rounded to 3 significant digits, so it'll stop at the 8, which will not be rounded up because it only has a 3 after it. All right, why don't you pause the video and try number 23. It's almost the same, except you'll be solving for VU instead of MU. And then when you resume the video, I'll have the work shown up here with the answer. All right, so getting back in here, I have the formula. I plugged in the numbers. These are the 2 known numbers. This is one of the numbers of the unknown substance, or the substance I don't know both numbers for. So it went on the side by itself. And then I solved for the unknown volume by dividing both sides by 0.2 and got a 44.5 milliliters for my unknown volume. All right, that wraps up our application review. If you have any more questions, feel free to email me or send me a comment on Google Classroom, and we can work on it.